This dashboard illustrates a startling reality. Across the globe, physical currency operates as a highly efficient, continuous collector and vector for both biological and chemical agents. Banknotes endure constant, unregulated human contact under wildly diverse environmental conditions. Yet, despite this endless cycle of exchange, they are virtually never disinfected. To understand how these hazards are actively sustained, we have to examine the metagenomic and toxicological profiles of global currency and look closely at the material science and banking infrastructure that makes it possible. Every physical banknote functions as an active, chemically and biologically dynamic microenvironment. The physical medium of the currency dictates its contamination level. Paper banknotes exhibit a pooled microbial contamination prevalence of 21.3%, significantly higher than the 14.8% found on coins. The reason lies in the material. Paper currency is manufactured from a highly porous matrix composed of 75% cotton and 25% linen. As a bill circulates, continuous mechanical stress breaks down its protective gelatin or starch sizing agents. This degradation exposes the raw, highly hydrophilic core fibers underneath. This creates micro-refugia, allowing bacteria and fungi to enter the cracks and shield themselves from desiccation. When torn currency is repaired with adhesive tape, it introduces a sticky polymeric matrix. This traps sweat and sebum, establishing a hyper-concentrated breeding ground for multi-species biofilms. Coins, by contrast, exhibit oligodynamic metal toxicity, meaning the metal itself inhibits fungal growth. However, they still support a 26.4% bacterial contamination rate, because bacteria can rapidly adapt and form biofilms even on metal surfaces. The physical degradation of the currency substrate directly dictates its efficiency as an environmental vector, rewarding microbial persistence. To see exactly what survives in these micro-refugia, researchers at the Catholic University of Cameroon assessed baseline microbial loads across Central African CFA franc denominations. This chart visualizes their data. Across all banknotes, the study found a 100% contamination rate for bacteria and fungi. The data reveals a high prevalence of severe nosocomial pathogens. Specifically, Staphylococcus aureus appeared on 35%, and Streptococcus pneumoniae on 12%. Most notably, they confirmed the presence of Mycobacterium tuberculosis, as well as agents responsible for acute bacterial meningitis. These pathogens map directly to cultural handling habits. Counting notes with saliva-moistened fingers facilitates the rapid deposition of respiratory droplets directly onto the fibrous paper. Furthermore, storing currency in unventilated, humid body microenvironments, like inside waistbands or undergarments, directly inoculates the notes with enteric and opportunistic urogenital flora. But the presence of the pathogens themselves is only half the threat. The sequencing also revealed the integration of antimicrobial resistance genes, or ARGs, within these microbiomes. The researchers identified 78 distinct ARGs on the Indian banknotes. These genes confer universal resistance to first-line clinical interventions, including penicillin and fluoroquinolones. Physical currency acts as an active distribution network, transferring multi-torg-resistant hospital strains directly into the general public. Beyond biological threats, paper money operates as a sensitive sink for chemical pollutants. Toxicological evaluations of U.S. currency show a staggering accumulation of illicit residues. Between 85 and 95% of all circulating U.S. bills carry detectable traces of cocaine. This phenomenon has expanded alongside the rise of synthetic opioids. Recent nationwide surveillance detected fentanyl on 63. This aerosolized chemical compound subsequently settles and homogeneously coats thousands of clean bills being processed in the exact same batch. This systematic homogenization has created significant legal and forensic fallout, particularly in civil asset forfeiture cases. Because background drug scent is practically omnipresent on general circulation cash, forensic toxicologists have successfully argued that a canine alert can no longer serve as definitive proof of direct involvement in the drug trade. It also creates acute occupational hazards. The Federal Reserve now enforces strict protocols, requiring any fentanyl-exposed currency to be double-bagged in tamper-evident plastic and quarantined from standard processing. Automated banking infrastructure inadvertently functions as a highly efficient nationwide homogenizer of toxic chemical matrices. From an epidemiological standpoint, it is important to clarify the baseline reality. For healthy individuals, the risk of acquiring an acute infection from casual, dry contact with currency is statistically minimal. The danger escalates at specific intersections, the first being commercial food service. A direct fecal-oral transmission route is established when vendors process contaminated cash and immediately handle ready-to-eat foods without proper hand hygiene, which allows these enteropathogens to rapidly replicate in the food matrix. The second critical threat intersection involves cutaneous or mucosal exposure in immunocompromised populations, where opportunistic pathogens on currency can bypass weakened immune defenses. The third intersection is high-volume occupational exposure in cash sorting facilities, where bioaerosols are concentrated. To mitigate these systemic biological and toxicological risks, public health officials point to 3 evidence-based policy interventions. The first is accelerating the transition to digital and cashless transaction networks. By completely eliminating the physical fomite from circulation, the transmission pathway is severed entirely. The second intervention is material. Mints must replace traditional cotton substrates with advanced polymer banknotes, which are engineered specifically to deny pathogens the microscopic structural anchoring sites they need to survive. The third involves implementing rigorous occupational health controls within commercial banking infrastructure. This requires HEPA filtration and automated UVC sterilization systems to neutralize pathogens in real time during processing. The physical banknote serves as a complex environmental sink, necessitating rigorous global public health protocols to manage its role in disease and toxin transmission.